some hard commitments on some of these answers, and so and it would, you know, everyone that's here wants the same information. So I mean, it's y'all show. I'm just asking, should we, the group of us that all have questions, come over here at one time, or would you rather us wait until you're ready?
No, I mean, we can come and stand over there if you want to ask
I mean, it's
that way. It's fine. I mean, if we know the answers, we can provide it based on what's been submitted, and if we don't, we can take note of that.
Okay.
Okay, folks, here's how it's going to happen for you. These four individuals are going to answer your questions, and they'll take the time to explain them fully to you. And though you know a lot more than I do for sure, but they will answer your questions the best of their ability. So, and they're going to do it in this format so you all hear every answer. Otherwise, I asked them about 30 questions and nobody heard any of the answers that I asked of the questions.
Yeah, can you introduce yourself and how?
Me?
Yeah, everybody. You want an introduction from everybody.
I got name tags.
Oh, I don't.
Right.
He's a concerned citizen.
What?
I will tell you who I am. I'm Don Lowry. I used to work down here. I live 18 miles as the wind blows from the plant. I am a concerned citizen.
You're in the zone.
Exactly. And so I'm asking questions. I'm also a licensed riverboat pilot, so I worry about what happens in the river. Now that's the basis that I came to ask questions, and they're answering them, and I'm sure they'll answer your questions.
You're almost a lone duck, aren't you?
No, the mayor's back there.
Well, he's
You know, I always measure how successful I am by who's got the ties.
a city official.
That just gives you something to grab hold of.
Well, but not me, Mayor. Maybe you. These are the gentlemen, and I guess you all can...
Sure, I'm glad to start. My name is Matt Gavin. I'm a geotechnical engineer and a design manager with a company called someUSW. We're contracted to Honeywell to do the design of the pond enclosure.
I'm Sean Chisek. I work for a firm called Andrews Engineering. We help Honeywell out with kind of routine environmental compliance, and we've helped them out with Illinois EPA, preparation of the Illinois EPA permit application for this.
My name is Jerry Williams. I work with a company called Enercon Services. We work with Honeywell providing some of the technical support for the NRC-related issues.
And I'm Mara Hollenbeck. I also work with someUSW with Matt and with these folks, and also my consultant to Honeywell helping on this particular pond closure project.
Closed out a pond out there approximately about 8 years ago. And that pond was dug up and shipped out. And it was shipped out as hazardous waste. When it left the site, the shipping instructions and everything, all the permits and everything had to be
Things in regards to
for
the question,
hazardous.
because I formerly worked at the IEPA, and I was the Illinois EPA's program manager for the Metropolis facility. And I kind of worked at IEPA when APON was being closed. And when APON was closed, at the time, they submitted documentation showing that if the material did not have any free liquids in it, the material would not be considered a hazardous waste. It's kind of the way the hazardous waste regulations work. The concentration of various chemical constituents such as metals, is below any sort of, the acronym is RCRA, or Resource Conservation and Recovery Act, RCRA. The concentration of constituents in the material is below the hazardous waste limits, and when the material from APON was removed and sent to Texas, they were allowed to ship it as non-hazardous waste.
Well, now a truckload of that got dumped on a field in Texas.
Right.
And they had to go out there and clean that up. If it wasn't hazardous waste, what was the big deal?
Well, they would have to go out there. There's kind of two things. And as part of, EPA's closure process, in that case, you know, they required, you know, you must send us copies of all your shipping papers that indicate, you know, you chose this facility in Texas to receive the material, and we want documentation that they received all of the material that you sent them. So, like, you know, it's not something where, you know, it's hazardous bad, it's non-hazardous good. It's something where, you know, material is what it is, and that you have to manage it in accordance with the regulations. And at that time, it was making sure that that material got to the facility in Texas. So that's why they had to get it.
On speaking uranium, what parts per million do they classify in those ponds as not being radioactive?
Well, the NRC's definition of the source material is 0.05 weight percent, which is
I'm sorry, what?
0.05 weight percent, which is basically 500 parts per million. And the ponds are in the range of 200 to 300 parts per million.
The ponds are 200 to 300 parts per million.
That's right.
And we produce calcium fluoride at 1,000 parts per million.
I'm sorry, I don't understand your question.
We produce calcium fluoride sometimes at 1,000 parts per million.
We did it.
Produce calcium fluoride.
Okay.
Now that's producing. And we can't ship that out of the warehouse because of the high use. Because anything over 300 parts per million, we cannot ship. So I've seen samples that come up with 1,000 parts per million U, 1,500 parts per million U, and that's what we all understand what goes on in the ponds out there.
Mm-hmm.
Everybody knows what goes in those ponds.
Right.
Any liquor that leaves that facility.
Right.
And a lot of the mud. And when you produce a product that is supposed to be under 300 parts per million and you cannot, that product in the past was dug out of the ponds. We had a boat out there where we augered the muds back to a holding tank to make the calcium fluoride with. We had to stop doing that for the simple fact the U was too high. And what we're having a hard time understanding here is that we can't produce calcium fluoride out of the ponds because the U is too high, but yet we can close the ponds because it's non-hazardous waste material and it's below 300 parts per million.
On average, they're
About 250 to 350.
250, 350, and there are probably going to be spots that are a little above that, spots that are below that. When the NRC looks at closing something like this material, they're basically going to want to know what's the average concentration out there. And we did an extensive amount of characterization work on the ponds, and on average, that's what's out there.
How many samples
so
did y'all take of each pond, and then how deep did y'all go with the samples? Did y'all go to the bottom, did you just skim off the top, or?
Kind of both. We took samples, we divided the ponds up into grids, and on average the grids were roughly 36 feet by 36 feet, more or less. And we obtained samples, and probably some of you guys may have seen the people taking the samples. You know, the boats were dragged across the ponds. And the material was taken out of the ponds from surface to essentially as far as we could push our sampling probe without like getting too overly aggressive, pushing the probe down to get samples out to not impact the EPDM liner. So samples were obtained from, we pulled material out from surface to the area 14, 15 feet in depth. In those areas, we created what the EPA and NRC would call a composite sample, mix the material up, and send a composite sample in for analysis. In some of the squares, we took a sample from, say, the top half of the pond material and the bottom half of the pond material, and sent that in for analysis. So we have, in some of these squares that we divided the ponds into, there would be 2 samples taken. In other areas where just really kind of depended on how things looked in the field when we were obtaining samples. If there was a layer, you know, most of the material in there is grayed, a whitish color. If there's a material of different color, like there was some that was black, you know, we would pull a sample of that material and send that in. So when he says 250 to 350 as far as kind of the overall average of what's in the ponds, that kind of accounts for the squares where we took full top to bottom samples, where we took the kind of half, top half, bottom half samples, and where we took kind of the more different colored samples.
Now, you're with the Illinois EPA or was, right?
I was, I'm not.
Are you with the same group that walked around that missed these KOH muds that they storing on site that was supposed to be put back in the process within a year?
I'm not with that group, no.
Okay.
Here, I'm having a, do you all understand how EPF works? I mean, you know, what we do at EPF, you know, the environmental protection facility that we have.
Somewhat.
Well, I mean, I'm having a hard time believing, and I don't mean to be sticking on this, but when we ran that boat that was in EPON, when we ran that boat, we had to put a cable on the auger system. The auger system would drop down approximately, I think it would go down around 12 feet. We had to put a cable on that auger system that stopped at 6 feet. Because if we went below 6 feet, the muds that we were bringing out of the pond, that we produced, calcium, you know, we produced calcium fluoride, was too hot. In other words, too much high U. So we put the cable on there so we wouldn't get wouldn't go below 6 feet. We could kind of skim the top of it, and our U would not get high in calcium fluoride. But if you drop below 6 feet, like I said, I've seen it over 2,000 parts per million. So that's hard to understand. That's hard for me to accept that there's no U in those ponds. You're saying the amount of U that you say is in those ponds.
Right.
That's, I mean, I've worked, I've took a boat, I operated the unit that made the calcium fluoride, I took the samples, I wrote the samples down of the U, the parts per million that went to, that was called to us from the lab, and we had to put it in different areas because we couldn't ship it out. So, I don't understand how you all sample a pond, and I'm not saying it's your fault, I don't understand the sampling, because we're blending lime with it. We're blending with that when we make calcium fluoride. We're bringing that out of the pond, and we're bringing a little bit out of here, and we're blending it, and we're still getting that high U. I don't understand where a pure sample can come out of a pond and be below what you're blending. I mean, it doesn't make...
On an individual basis, I'm not saying that the samples are all between 250 and 350.
Yeah, I understand that.
When the NRC looks at the closure process, because of the way they deal with the materials, they basically we'll get our characterization data, which Sean described how it was taken, and they'll look at it and say, we're going to have this large block of material, a pond with all the material in it. We're going to put a stabilization additive in there, and they'll take the average concentrations of what's going to be there, and they ask us to, and that's part of our submittal, would be to run a dose evaluation and say, what's the dose that will come to somebody as a result of what's going to be there? If we do this process, mix the material, put the cover system on it, measure the dose. The dose from that material, I mean, we've had people walk around those ponds with dose rate meters. Dose rate meters around those ponds isn't any different than the dose rate you get walking down the street. Mix the material, that ties up the water, stabilizes the material, adds some strength to the cover system that was designed for it, and that process will be then to give that to the NRC and say, using this closure process, There's not going to be a measurable dose from this closure.